2014 kickoff. I'm Don Bosey, the new president of FIRST, and I'm joined here this morning by two gentlemen who really need very little introduction, Woody Flowers and Dean Kamen.
So we're excited this morning.
We have over 2,700 teams this year. Almost 400 of them are rookies.
Whose names are scrolling across your screen right now.
92 kickoffs. Countries having kickoffs: Australia, Brazil, Canada, Israel, Mexico, and of course the United States. We're here to do three things: say thank you for what you've done, welcome the new folks, and launch this year's madness. We're always trying to come up with new ways to keep things fresh and push the boundaries. So we're doing things a bit differently this year, making changes throughout the season from kickoff to championship.
Kate and Colin from FIRST are on location with this year's field, and we'll be checking in with them throughout the show.
Thanks, Don. Hi, teams. I want to start by thanking all of you who filled out the Kit of Parts survey after last year. We review the feedback, learn a lot from it, and hope you see improvements.
And thanks to the more than 100 teams that sent in their shirts. We're here on location as engineering puts together the new field. Before we take a look, let's walk through the structure of the kit. We want to make sure you don't miss out on some good stuff. You can break it down into three components: first choice, the virtual kit, and the kickoff kit. Let's start there.
Each team will receive a kickoff kit today, soon. Everyone gets a black tote, and rookies get an additional green tote. What's new this year?
There are two new ways to cool motors, with an Ice Cube kit from EBM Pabst or the Sim Cooler from Next Gen Robots. In addition to the new drive base configuration that Frank announced in his FRC blog, there's a second type of micro switch from Honeywell and springs from Vulcan Spring.
We also doubled the number of sim motors. There are 2 in the VEX kit and 2 as separate items. Good stuff. And here comes the field. We'll stay put and have more to show you when we come back later to talk about first choice.
But next, I'd like to introduce Jim Heppelman of PTC, kickoff sponsor, Kit of Parts supplier, and FIRST strategic partner.
Thank you. It's great to be part of another FRC kickoff. FIRST is really a great program. Back when I was in high school, FIRST didn't exist. Fortunately, I was a country boy who grew up around a lot of machinery, and how it all worked intrigued me. Couple that with good skills in math and science, and I was off to college to become an engineer. In college, I learned how computers could be applied to engineering, and shortly thereafter, I found myself working for an engineering software company. Later, when I saw those same computers being connected to the internet, I realized that this now meant that engineers could be connected and they could collaborate across global teams. So I became a software entrepreneur and set out to make that happen. PTC saw this idea and acquired my company, and over time the idea took off and I became the CEO of PTC. But now I see that the products and the machines that our 27,000 manufacturing customers create using our software are becoming connected to the internet too, so that they can be remotely monitored, serviced, and controlled. I'm talking about all kinds of things like cars and tractors and homes and coffee makers. Things that are not only mechanical, but also smart and connected. Just Google Internet of Things and you'll see a major disruptive technology wave is developing. In fact, this phenomenon has become a major focus of the advanced work we are doing at PTC. Smart, connected machines, Internet of Things? That sounds a lot like a FIRST robot, don't you think? Imagine that through FIRST, you are engaged in a neck-and-neck technology race with us professionals. Wow! Think of what that experience means. The jobs you can get, the careers you can develop, the problems you'll solve, the money you'll make, and the fun you're going to have. What a special program and a special opportunity that FIRST is. The 6,000 employees of PTC are proud to sponsor this event and proud to be a strategic partner of FIRST.
Jim Heppelman is a great friend of FIRST.
Don, we've got more than 3,000 great friends at FIRST among all of our sponsors, and they've delivered to us last year in excess of 120,000 volunteer mentors and supporters. What makes FIRST work is this incredible community of passionate technology companies, teachers, parents. It's unbelievable.
Could you ever have envisioned that in the beginning? How'd you get from then to now?
In that first kickoff, I had a slide that said gracious professionalism. After the kickoff, Dean said, more gracious professionalism. So the next time I had 6 slides that said gracious professionalism, and it has taken on such a life of its own in the ethos of FIRST.
I think gracious professionalism is as much of a hallmark of FIRST as lots of the other things that make it special. We're really not building robots here. We're building character. We're building self-respect. We're building relationships between kids and the superstars of the real world.
We've come a long way. Good to see FIRST teams and their work celebrated. And it's all because we've had such dedicated mentors and sponsors out there year after year. Thank you. Now, NASA has been a huge part of FIRST growth.
Hello, I'm John Grunsfeld, the head of science at NASA and a 5-time flown shuttle astronaut. I'm talking to you from the surface of Mars. Well, okay, not really, but one day perhaps you will be exploring Mars and it will look something like this. In fact, behind me is Gale Crater on the Martian surface, as seen by the Curiosity rover, a robotic explorer currently on Mars. Teamwork and robotics will be the key to success for a future human mission to Mars. What you're doing will help NASA get there. I congratulate all of you for participating in this year's FIRST Robotics competition. But this is more than a game. This experience highlights what you will do in your careers. Experience in this competition is similar in many ways in how we design, build, and test NASA robots. Engineering design, testing some more, real deadlines, and of course working in teams is vital. Creating something like the Mars rovers or the Robonaut humanoid robot currently flying on the International Space Station takes the same kind of ingenuity and creative problem solving as your work crafting the robots to face this year's challenge. NASA looks forward to seeing the innovative solutions you develop and seeing how your solutions might help or inspire development of our future spacecraft, and yes, a future human mission to the Red Planet. Good luck, and above all, have fun.
And I'd once again like to personally thank one of our great long-term sponsors and supporters, NASA. This year, again, they're broadcasting to 92 kickoff locations this event and throughout the season and at our championships. We've counted on NASA for inspiration, excitement, support, mentors for nearly 2 decades now. And I hope in the future you'll continue to give us the kind of support you've given us all along. By the way, speaking of kickoffs, we kicked off another event this year. 5 FIRST robots cut the ribbon on the world's most famous parade, the Thanksgiving Day Parade sponsored by Macy's in New York. And the goal, of course, is to make FIRST part of everything we do in our culture.
That's right. FIRST is out there changing lives. You know, just one example, this great new movement has started in the United States called the Maker Movement. And it's really important. It's related to what FIRST does. And a former FIRSTer, Dr. Dawn Wendell, has now become part of the admissions office at MIT. And because of a lot of her effort, when you apply to MIT, you can put some of your accomplishments, images, videos of the things that you've built into your application. That's very different than it was 20 years ago. Colleges are not looking for just scores, they're looking for evidence that you can really do things.
And here's an example of how FIRST changes lives. This year, over 160 university partners are providing more than $18 million of FIRST-related scholarships. Let's hear from some recipients. And all of you, remember, apply, apply, apply.
Hey, I'm Sarah. I'm Pascal.
And I'm Sophia. And we're all FIRST Scholarship recipients.
We are here at the UNH Emerging Technology Center in the historic Pandora Mill building. It's a resource for students, local businesses, and academics to experiment together on real-world projects.
I'm an alum of Whitney High School Robotics in Southern California. I'm using my FIRST scholarship to go to the University of California, Berkeley this year, and there's no reason you shouldn't try to do the same. One of my team mentors found out about the FIRST Scholarships program for us. Our mentors teach us so much more than robotics. The skills I gained fundraising and grant writing for my robotics teams really helped me when it came time to work on those applications.
I was on Team 4266, New Oxford Robotics. One of my mentors also pointed me to the FIRST Scholarships website at usfirst.org/scholarships. I was surprised to find opportunities that were not just for engineering majors. My scholarship is making it possible for me to major in biology and political science at Wake Forest.
I'm from Team 1425, Error Code 0 in Oregon, and I'm at University of Washington thanks to a Bart Kamen Memorial FIRST Scholarship. I didn't think I had any business applying for a robotics-related scholarship. The competition, I know kids on my team who didn't apply for opportunity would be so tough, but I'm really glad that I did. I know kids on my team who didn't apply for opportunities I'm sure they deserve to win. The most recent National Post-Secondary AIDS study estimated that almost $3 billion in scholarship money, you know, the kind you don't have to pay back, was awarded to over 1 million people in a single year.
Being a firster can make it a lot easier to qualify for some help. You have to check out the FIRST Scholarship page at usfirst.org/scholarships. You'll find almost 900 scholarship opportunities from over 165 different providers. The total value is over $16 million. Most scholarships are available for FRC and FTC participants. Not all awards are restricted to STEM-related majors, but they all value FIRST participation in a specific way.
That's right, about 35% are for any major you choose. They're from schools in 35 states and 4 countries, and the values range from $500 to full tuition. Some of the awards offered by corporations and associations are even portable. You can use them at any institution you choose.
They're a bit like the FIRST rulebooks. The details count, so read through them carefully. The FIRST Scholarship page has filters that can help you narrow your search. The most important thing to remember is
apply, apply, apply.
No one ever received a scholarship they didn't apply for. You can't start too soon. It's not hard, but it can be hard to get started.
How do you get started? The FIRST Scholarships webpage is a great resource. Go to usfirst.org/scholarships. There's everything you need to get you going.
Good luck, and we'll see you on campus.
Sarah, Pascal, and Sophia, congratulations. Now let's talk about the second way to get your parts, First Choice, the online distribution system hosted for free by AndyMark. Log on to the site and use your FIRST credits to claim items. You just have to cover the shipping.
As of noon today, each team will be issued 450 more credits. There are limited quantities of some items, and it's first come, first served. So move quickly on items you're sure you need. The system will be open through April 18th.
New items in First Choice this year include Texas Instruments Launchpad, bearings from Schuster, and switches for I/O from NKK Switches.
You can find Xbox gamepads from Microsoft, limit switches from Honeywell, V-belt pulleys from FRC Team 1810 and Levick Plastics, tools from Grainger like strap wrenches and job saws.
Thanks to a coordinated and dedicated effort from the Department of Energy, Oak Ridge National Laboratory, America Makes, Tennessee First, and Tech 2020 3D printers. America Makes has also coordinated the donation of 3D print vouchers and software.
So cool. Thanks so much. Meanwhile, engineering has made some progress here. This component looks all wired up and ready to go. Stay tuned to see what it's for.
I'm a rookie, and I know there's a lot of other rookies like me out there this season. And we're in for 6 weeks of hard fun. And sometimes we're going to fail. What advice do you guys have?
You know, you don't wake up one morning and decide you're a creative person and actually make that happen. You have a series of exercises that allows you to develop some self-confidence so that you can rely on being creative. Same thing about leadership, right?
And by the way, Don, watching kids learn how to fail and move on is one of the great things about FIRST, because FIRST is a microcosm of the real world. You know, we develop water systems for the developing world in my day job, and electric generation systems, and artificial organs, and prosthetic devices. And many of them become instant overnight successes after we work on them for 10 or 15 years. And we fail a lot, but we learn from those failures and we keep moving. And FIRST is a microcosm that in 6 weeks they can fail a lot, but they can learn a lot in a very forgiving environment.
You don't tell your guys to go come back with the right answer check?
I looked in the back of the book. I shake the book, I shake the book. It only has the answers to the problems that have already been solved in the world.
How do you think this is relevant to what the kids are learning in school? How is this relevant to their education?
Oh, it's really important that they learn the stuff. The codified knowledge is really important, but building on that, learning how to go further than that is what's really important.
I think to succeed in the 21st century, you need 2 things. You need the analytic capability. That's what school teaches you. Math and science, how to analyze a problem, what's been done. We stand on the shoulders of giants. You don't have to invent Archimedes' principle. He gave it to us 2,200 years ago. But after you get all that analytic set of stuff, you need to synthesize it. You need to take all those tools and build something new and different to solve a problem that's never been solved. Schools are pretty good at giving the analytics stuff. We, FIRST, partner up with these schools and with industry and let them do the synthesis. See why they learn. Why do they have all these tools? Because with those tools, they can solve the world's problems. And in only 6 weeks, they get to solve a pretty exciting one.
The competition is a celebration of all that stuff that's happened up to then.
Look at it this way. Winning the game is fun. It's 6 weeks of fun. The importance of FIRST is that it's going to change the rest of your life. The game is fun. The Chairman's Award will show you how serious FIRST can be in creating your future.
The Chairman's Award, given out each year, embodies this philosophy. We appreciate the leadership and vision of outgoing Chairman Walt Havenstein.
Congratulations on winning the Chairman's Award. And from those of us in New Hampshire, we're wicked proud about all of you guys from San Diego. Why are you named the Holy Cows?
The story is that originally we were called a Fistful of Motors in our rookie year, but we found that it was really unmarketable. Like, we couldn't really do anything with the name. So we were coming up with the names on the board, like a whiteboard, and then our school's director came in. And what happened was he was like, holy cow, that's a lot of names.
How does it feel to be the winners of the Chairman's Award?
Really good.
And now let's hear from last year's award-winning team.
My name's Ambar.
Mario. Jeremy.
Henry.
And for 3 years,
The past year,
4 years, I loved being a member of the Holy Cows.
though I joined because of friends,
because I needed an extracurricular activity,
Because I was fascinated by the robots they drove at my middle school.
I was immediately
hooked.
Being on the Holy Cows has allowed me to make a difference in the community.
I have helped raise over $2,000 for cancer research.
And over 1,000 pounds of food for families.
We completed over 13,000 hours of community service in 3 years.
We volunteered at elementary and middle schools to excite kids about FIRST.
I have worked with City Councilwoman Sherry Leitner,
former San Diego Mayor Jerry Sanders,
And the State Superintendent Tom Turlaxon.
To improve STEM education in California.
I'm working with the California government
To have robotics recognized as a statewide sport.
Being on the Holy Cows has helped me create new resources for FIRST teams.
I have co-hosted Battle at the Border,
An off-season competition that doubled as San Diego FIRST Day.
I helped design Cow Scout,
the largest database of FIRST competition data anywhere.
And I've turned it into a tool to make FIRST more accessible to the public.
I've expanded Cow Tips, our online tutorials for FIRST teams.
I've helped run our 4th annual fall workshops.
Where presenters from across the country came to speak to teams.
I've mentored teams both locally and across the world.
And have hosted one-on-one workshops.
And a Kickoff Build Day for rookie FRC teams.
Being on the Holy Cows has helped me reach out to programs that inspire tomorrow's technology leaders.
I remember high-fiving the winning teams at our FTC tournament.
And seeing the shocked faces as I announced the winners of our FLL qualifying tournament.
I'm collaborating with the San Diego Festival for Science and Engineers
to host a hands-on engineering workshop for middle schoolers.
And next year, I'll be working with them
to hold a workshop for teachers on how to incorporate FIRST ideas into their curriculum.
Being on the Holy Cows has allowed me to give back to the program that has given me so much.
This year, I've worked alongside our neighbors, Team 4160,
to set up a field for Southern Californian teams to practice.
I helped build a mobile machine shop that will be used at every Southern California regional in 2013.
After high school, I helped start a robotics competition for inner-city schools called Pioneers in Engineering.
Before I was on the Holy Cows, I didn't think a career in science and technology was possible.
And though I'm not going into STEM, I've realized how important it is.
I've become a better public speaker and communicator.
I became more confident,
more outgoing.
I've taken on the responsibility to become a team leader.
I decided to study mechanical engineering at the Worcester Polytechnic Institute because of my time on the team.
By being on the Holy Cows, I've gotten an internship at Solar Turbines.
Spay War.
These kids are my family.
We help each other outside of robotics.
We were there for each other when we lost a team member to cancer.
So we leave with these words by Harriet Tubman.
Every great dream begins with a dreamer.
Always remember, you have within you
the strength, the patience, and passion
to reach for the stars to change the world.
We're lucky to have Bob Tuttle and Sherry McCoy, both longtime FIRST supporters, as our new co-chairs of the board. Here's Sherry McCoy.
Thanks, Don. I'm excited to be co-chair of the FIRST board with Bob Tuttle. We're looking forward to an amazing FIRST robotics season. I started at Johnson & Johnson as a chemical engineer back in the 80s and ended up as vice chairman. I know firsthand how challenging it is to be a woman in the science and engineering world, and what a positive difference diverse perspectives can make. We all have an important role to play. As students and mentors, you have the opportunity and power to make the next generation of scientists, engineers, and innovators more inclusive than ever. As head of the world's largest organization of women entrepreneurs, the Avon Company, I engage with women everywhere and every day to help them achieve their potential. Here's what I know about empowering people. They want to get in the game. Grab your friends and get them involved in the FIRST experience. Show them how satisfying it is to solve problems and work together as a team for the benefit of all of us. See you soon and have fun.
In just a little while, you're going to tackle this year's challenge. And you're going to find out that there are lots of ways to try to make this work.
In fact, I think what you're going to find is that grit is something that's really going to define you as you go through this.
You're going to have to try something and bounce back and try it again. And it's very likely that your mentors are going to offer some help.
But we all know that the most valuable thing our mentors deliver is their time, but it makes a difference. So I want to thank here today every mentor for what you have done and what you will be doing for FIRST. It really makes a difference, and it is going to change the lives of a whole lot of kids.
And amazingly, in 6 weeks, you're going to accomplish things that you didn't think were possible.
Speaking of hard work, Kate, Colin, what's going on?
Thanks, Woody. We've covered the kickoff kit and first choice. The third piece is the virtual kit. We've added items there too. These parts never actually come to FIRST. They're delivered directly from the supplier to you. We just coordinate the handshake.
Some items are tangible, like Bimba's cylinders. They're back with their 3-cylinder donation. Just let them know the bore and length you need, and they'll ship right to you. Other items, like bulk and spring, use vouchers. You'll find some voucher codes in Tim's and more on flyers in your kickoff kit. Lots of these vouchers became active on December 14th.
The intangible items are all software. New to the virtual kit this year is SolidWorks. We're happy to have them officially on board. We'd also like to welcome products from Tableau, GitHub, and 3D Systems to the virtual kit.
Thank you to all of our suppliers. We recognize them on our website, and a few, like FedEx, National Instruments, PTC, and Rockwell Automation, donate to the kit and are FIRST strategic partners.
Now, let's take one final peek at the assembly here. Matt's installing the Allen Bradley display in the Alliance Station. It won't be long now until this makes sense. Thanks for having us, guys.
Okay, here we go. This year's game is really different.
I'll give you a little tip. The Alliance members are going to have to work really closely together this year on the field.
Teamwork rules, and will have a big impact on your score.
And now, the moment you've all been waiting for, the 2014 FIRST Robotics game, Aerial Assist.
Welcome to the 2014 FIRST Robotics Competition and this year's game, Aerial Assist. Aerial Assist is played on an approximately 25 by 54-foot field. Alliances of 3 teams each operate their robots from behind alliance walls at the ends of the field. 2 large scoring goals are located at the top of each alliance wall above the driver stations. 2 smaller scoring goals are at the lower corners of the alliance wall. The center of the field is spanned by the Truss, which is approximately 5 feet above the floor. The field is segmented into 3 equal-sized zones, red, white, and blue. Additional goalie zones are at the ends of the field, between the pairs of low goals. Aerial assist is played with 2-foot diameter exercise balls, colored red and blue to match the corresponding alliance. The objective of aerial assist is for teams on an alliance to work together to advance the ball down the field and score into their alliance goals at the far end of the field. A ball scored in a low goal earns 1 point. A ball scored in a high goal earns 10 points. Robots that assist their alliance when scoring will earn big bonuses. The match begins with each robot starting in the white zone or a goalie zone. Each robot can be preloaded with 1 game ball. A 10-second autonomous period starts the match. During this period, robots use pre-programmed instructions. Each ball scored during the autonomous period earns a 5-point bonus. 1 set of goals will be lit up and hot during each half of the autonomous period. Each ball scored in a hot goal gets an extra 5-point bonus. And every robot that moves from the center white zone into their own zone during autonomous gets another 5-point bonus. At the end of this period, human drivers step forward to take the controls. As the teleoperated period starts, teams command their robots to score as quickly as possible. A scoring cycle starts as a human player transfers a ball onto the field. Robots can just take the ball and run directly to the other end of the field to earn the basic goal score. But receiving assistance from your partners in moving the ball down the field will add bonus points. Alliances that use all 3 robots to assist the ball through all 3 zones will earn the most points. Throwing the ball over the truss on the way to a score will add a 10-point bonus, and having your alliance partner catch the toss will add another 10 points. Of course, robots will have to be built robustly to avoid damage from falling balls. Meanwhile, 1 robot in the goalie zone can extend upwards to block shots and defend the goals. Alliances try to score as many points as they can during the 2.5-minute match. Good luck, and we'll see you at the competitions.
And now here's the code.
See you at the competitions.
Good luck. Stay in touch. We're going to show you some more detailed field explanations, and these will also be available on the web, so feel free to stick around or not. All the videos that follow this can be found on the FRC YouTube channel.
And now, start your engines.
The spec of the ball is defined by size, about 25 inches. Here's what you can expect at events and how you can make sure you've properly inflated yours at home.
There's a small plastic stopper in the fill spout of the bladder. Remove the stopper and put it aside, but don't lose it.
Unfold the cover and find the zipper, but don't turn it right side in yet.
Position the zipper like this. Now, pull the cover through the zipper opening until it's completely right side out.
Insert the bladder into the zipper hole, keeping track of where the fill spout is located. It may take some fussing to insert the bladder into the cover. Be careful not to tear the bladder or stress the zipper or the seams.
Center the fill spout in the zipper opening. Shake downward to encourage the bladder to spread out inside the cover.
Begin to inflate the ball, stopping occasionally to keep the fill spout well centered in the opening. Inflate the ball so that it looks just right. When properly inflated, the zipper will work easily.
This ball is underinflated. This ball is overinflated.
The seams are another good indicator. If wrinkled and loose, it's underinflated. If taut and not about to bust at the seams, it's about right. If stretched and overstressed, it's too full. When you are happy with the pressure, insert the stopper all the way and pull the zipper closed.
The first time you inflate, the cover will stretch. If this occurs, or the temperature changes, you may need to adjust the amount of air in the ball. Now you're ready to play aerial assist. Thanks for watching and good luck.
Let's talk about Truss. An aluminum entertainment truss bisects the field. It's 12 inches square and is supported by stands outside the safety barrier.
The truss is positioned such that the bottom is 5 feet 2 inches from the floor, and the top is 6 feet 2 inches from the floor.
At each end of the truss are truss poles. They are 4 feet tall, but remember, the plane they mark is infinitely tall. These mark the boundary of the field and help indicate if a ball scored over the truss did so in or out of bounds.
Indicators on the truss show teams and the audience if the alliance has earned a truss score for that particular cycle. If the light's off, the Alliance is eligible for a Truss score. If the light's on, it means the Alliance has earned the Truss score and can't earn it again until a new cycle begins.
There are high and low goals. The Alliance scores in the goals that match their color. Low goals are open cubes in each corner of the field. Side openings are 2 feet 5 inches wide by 2 feet 4 inches tall. The top opening is a 2 foot 8.5 inch square. The bottom edge is 7 inches off the floor. Once a ball is scored in the low goal, it rolls out the back. There are 2 high goals for each Alliance over their opponent's wall. Each goal is 3 feet 1 inch high and 11 feet 6 inches wide. The outside of each goal is a semicircle with an 18.5 inch radius. Light strings trace the perimeter of each high goal. They're decorative and informative. During auto, the hot goal is outlined in yellow. The light strings also indicate how many assists the Alliance has earned. For 1 assist, the inner third of the goals are illuminated. For 2 assists, the inner 2/3. For 3, both high goals are illuminated in the Alliance's color. The field is divided into 3 zones, red, white, and blue. The white zone is in the center, outlined with white tape. The red and blue zones, also marked with tape, are at the ends of the field and match the goals. Zones play an important role in auto scoring and are also key to getting assists and teleop. Make sure you read the game manual to fully understand assist criteria. Each Alliance has a goalie zone in front of its opponent's goals, bounded by the low goals, Alliance wall, and black tape. One defending robot in its goalie zone has no height limit. Make sure you read the game manual for those details. The key feature in the game this year involves earning bonus points by passing your ball before scoring. We know that it's important that you know what the referee has acknowledged, and we share that info in a few different ways.
The information conveyed on the front of the goal is replicated on the back. Ball possessions in each zone are communicated via light strings on the player stations. For example, this light string shows that the robot has been recognized for ball possession in both the red and white zones. You can also see your opponent's light strings.
Remember, possession alone doesn't automatically translate into an assist. They're awarded for unique robot zone pairs. Make sure you study the manual for the nuances here. Actual assist assignments are displayed on a 3x3 matrix behind the Alliance wall.
Here's an example of an Alliance that had possession in all zones, but only used 2 robots to advance the ball, earning 2 assists. You won't be able to see this detail for your opponents, so you'll have to track it yourself. Human players aren't restricted to the Alliance station this year. Each Alliance has 2 human player areas on the far side of the truss.
Each area is a 2 foot 6 inch by 12 foot 10 inch rectangle. From these positions, they'll be able to help keep balls in bounds and pass to their robots. Make sure you read the game manual for specific rules about what these players may do and where they may go. The field is equipped with targets for teams using vision. Each target uses 3M's retroreflective tape. It's the same tape used last year, and it's in your kickoff kit.
Cameras see light reflected by the tape very well when the light source is adjacent to the lens. This reflection can be used by drivers or software to easily identify the targets.
The first set of targets are located on either side of the player stations, made up of a 4-inch wide, 32-inch tall strip of retroreflective material, bordered by a 2-inch wide strip of black tape on each side. These strips begin 3 feet 1.5 inches above the floor and are at the inside edge of the low goal.
The second set of targets are horizontal and dynamic, much like these videos. Located above the low goal, they change to indicate which goal is hot. These horizontal strips, 23.5 inches long and 4 inches wide, are surrounded by black plastic. They sit 5 feet 8 inches above the floor, centered above the low goal.
When a goal is hot, the retroreflective material rotates to face the field. When the goal is not hot, the material rotates away.
This video is dedicated to details about possessions and assists. Specifically, a possession doesn't always result in an assist, and credits for assists can change during play.
We're going to walk through the examples presented in the manual. Here are a couple of ways an Alliance can earn only 1 assist. In the first example, the inbounder passed the ball to the robot in the blue zone.
The robot possessing the ball in the blue zone results in an assist. The robot then drives the length of the field possessing it in each zone. While the ball was possessed by the Alliance in each zone, they only earned 1 assist and 0 extra points because no other robot contributed to the effort.
In the second example, you can see that the same red robot picked up the ball in the blue zone, but then passed it off to robot number 3, also in the blue zone. Because this all happened in the same zone, there's no second assist for the second robot's possession.
Now let's look at the 2 assist examples. First, Red Robot 2 picks the ball up in the blue zone. It carries it to the white zone and then hands it off to Red Robot 1 in the red zone. The unique robot zone pairs are Red Robot 2 in the white zone and Red Robot 1 in the red zone. The field system could have granted Red Robot 2's assist for possession in either the blue zone or the white zone, but not both.
The second example is a little more complicated. It starts out the same. Red Robot 2 gets the ball in the blue zone and drives to the white zone. Then, Robot 2 passes to Robot 1. Robot 1 then takes the ball to the red zone. The unique robot zone pairs that the field system grants assists for are Robot 2 in the blue zone and Robot 1 in the white zone.
For the last 2 assist example, let's assume that Robot 2 gets the ball in the white zone and passes it to Robot 3. Robot 3 drives to the red zone and passes it to Robot 1. Assists are granted for Robot 2 in the white zone and Robot 1 in the red zone. Ultimately, as you may have figured out by now, assists will never be granted for possessions that share either a row or a column.
Finally, let's walk through some 3 assist scenarios. These are the most lucrative, so it's important to understand how to earn them and how they could fall through. First, Robot 3 grabs the ball in the blue zone and passes it forward to Robot 2 in the white zone, who then forwards it to Robot 1 in the red zone. Each robot zone possession is distinct, so the Alliance gets credit for the 3 assists.
The second example starts the same way. Then Robot 1 manages to gain possession of the ball in both the white and red zones. Because Red Robot 1 is the only robot to possess the ball in the red zone, it forces the field system to grant the assist for the white zone to Robot 2.
In the third example, the only robot to possess the ball in the blue zone was Robot number 3. It automatically gets credit for that assist, same for Robot 1 in the red zone. Because Robot 2 only possessed the ball in the white zone, it automatically earns that assist, even though Robots 1 and 3 also had possession in the white zone.
The last example is much like the second one, except Robot 1 has possession in every zone. The last thing we want to cover is a nuance about non-linear scenarios. Let's assume there's aggressive blue defense and it's not a simple drive down the field. The inbounder feeds the ball onto the field. Robot 1 takes possession there.
Boom! Assist number 1, right?
Yep. It'll be indicated in a few different ways. If you've seen the other videos, you'll know that lights around and behind the goal will show this.
Okay, now Robot 1 forwards the ball to Robot 2, who's also in the blue zone. No new assist because the zone is still a common element. Robot 1 drives to the middle of the field. Once Robot 1 gets to the white zone, Robot 2 passes to Robot 1.
Boom! Assist number 2, right?
Yep. Again, indicated by the lights on the field. If you're watching the display in the Alliance station closely, you'll notice the field system changes who gets credit for the assist in the blue zone. It started as Robot 1, but once Robot 1 takes possession in the white zone, the blue zone assist is shifted to Robot 2.
Now Robot 1 forwards the ball to Robot 3, who is also in the white zone. No new assist because there's no new unique robot zone pair. Robot 1 drives to the end of the field. Once Robot 1 gets to the red zone, Robot 2 passes to Robot 1.
Boom! Triple threat, right?
Yup, the goal is fully lit. Assists indicated in real time by field lighting don't necessarily match the assists highlighted on your display. That's because the field system adjusts the actual possessions it's using for assists to preserve the robot zone uniqueness to award the maximum number of eligible cases.
The Field Management System, or FMS, is the backbone of the arena's scoring and communication system. This video will make it more transparent to you. The details are also covered in the FMS white paper that you can find on the FIRST website.
The FMS encompasses all the controls for the field electronics and robots. It manages the event by creating match schedules, operating field hardware, scoring matches in real time, hosting information to the audience screen, and uploading results data to the internet.
Components such as the driver station and the ref's touchscreens integrate with FMS through direct wired Ethernet. The e-stops and stack lights mounted in each player station interface through Ethernet-based I/O modules that are donated to FIRST by Rockwell Automation.
The light strings are controlled via Ethernet-enabled power supplies donated to FIRST by Philips Color Kinetics.
Two core components control the robot: the C-RIO controller and a computer running the FRC driver station, or DS, software. The DS is the master controller. The status and actions of the robot are determined by commands from the DS.
Packets from the DS are broadcast by the integrated radio in the DS computer, by a separate radio like the access point used on the playing field, or through a tether. The D-Link radio on the robot receives the packets from the DS and forwards them to the C-RIO. Status packets from the C-RIO are sent to the DS after each received command packet.
On the competition field, packets from a DS are routed through the managed switches in the station control cabinet and Scorpion case to the field access point, which then transmits the packets to the appropriate robot. The D-Link radio on the robot receives the transmissions from the field access point and forwards the packets to the C-RIO.
The FMS communicates with each DS via the field's Ethernet network and employs team-specific VLANs, which serve to isolate each team's data traffic. The FMS doesn't communicate with robots directly. It gathers data from the DS about a robot's status and tells the DS if it's enabled, disabled, or e-stopped, and if the robot should be in autonomous or teleoperated mode. It also tells the DS its player station and alliance color.
If a team stack light is flashing, the FMS doesn't think your DS has a connection to your robot. There are two common ways for this condition to occur. The DS is not communicating with FMS, or the DS is telling FMS that it cannot communicate with the robot.
The FMS configures the managed switches and field access point before each match to ensure that data and communications for each team are kept separate. Each team has its own VLAN, ensuring that the command packets from one team's DS do not cause a response on another team's robot. These VLANs exist on both the wired and wireless side of the playing field's network.
That's why it's necessary for a team in blue player station number 1 to connect their DS into the corresponding cable for that station. On the wireless side of the network, VLANs are configured prior to the start of each match so that only the 6 teams assigned an FMS may operate.
That's why it's necessary to configure your D-Link radio at the kiosk at each event your team attends.
After VLAN setup is complete, which is called match pre-start, the FMS sends out command packets to the 6 DSs. When a team plugs their DS into their Ethernet cable, the DS receives these command packets and switches into FMS mode. FMS Connected is displayed on the DS Operation tab. The DS continues to serve as the master controller for the robot, but state and mode are dictated by the FMS. The FMS tells the DS what to do, and the DS then tells the robot.
Practice mode, which you can use at home to simulate match timing, and FMS mode, which happens when you're connected to the field, do have differences, but the majority of the functions are identical. Both operating modes step through the same states, which are listed and described in more detail in the FMS white paper.
Joysticks are handled a bit differently between the two modes. In practice mode, unplugging a joystick will result in the robot being switched to disabled. This is designed to be a safety feature, as the robot may be running in a variety of environments that might not be equipped with barriers to safely contain the robot.
Unplugging a joystick in FMS mode won't result in the robot being disabled. If a joystick becomes disconnected, simply plugging it back in will not result in it returning to normal operation. The user must press F1 on the DS to manually rescan the USB interface to redetect the joystick. More details on why are included in the FMS white paper.
Finally, the network port used by the DS to send command packets to the robot is different in practice mode from the one used when in FMS mode. Details about the network ports are included in the FMS white paper and the arena section of the FRC game manual.
The practice field at your event isn't integrated into the FMS at all. It uses a different field access point and doesn't employ VLANs. In fact, if you want to operate wirelessly on the practice field, you'll need to use a FIRST supplied radio that's configured specifically to operate with the practice field access point.
The FMS incorporates bandwidth limiting for each team. The limit is 7 megabits per second on the competition field. We strongly recommend that you incorporate this bandwidth limit for practice at home to mimic the FMS environment. Details on how to do this are included in the FMS white paper.
The FMS gives control and status packets the highest priority on the network. Even though teams may be using more network bandwidth, control and status packets are prioritized over other user data, like camera feeds.
These are the conditions to expect when on the field and how they may differ from those at home or on the practice field. Taking the time to understand these parameters will help you better prepare for competition and troubleshoot any surprises.
Good luck.
Let's check out what's going on behind the Alliance wall. Each one has 3 identical player stations. Each player station has a shelf for operator consoles with a strip of 2-inch hook and loop tape, loop side up.
Each player station has an Ethernet cable which connects your operator console to the field system. The e-stop button lets you disable your robot if necessary. New this year is an AC outlet for your operator console. Each outlet has just a 3-amp circuit breaker, so be careful not to trip it. If you find yourself in the middle station, watch out for the cabinet under the shelf.
Above each station is a set of stack lights. They relay diagnostic information. The bottom amber light indicates if the e-stop has been pressed. The top 2 lights match the Alliance color. They convey a few different things. If they're off, it's before the match and the robot is linked but disabled. If they're on, the robot is connected and enabled, so you'd only see this during a match. If they're flashing, it's because the robot isn't connected to its driver station.
The white starting line is 2.5 feet behind the Alliance wall, and everyone must stay behind it during autonomous. The Alliance station is bounded by the Alliance wall, the back of the low goals, and white perimeter tape. The inbounder can feed the ball to the field without having to go over the Alliance wall.
Each player station has a light string. Most importantly, it's only safe for people to enter the field when the string is green. During the match, it indicates the zones in which the team has been granted possessions. Make sure you watch the Robot Zone Indicators video for elaboration on that specific behavior.
Each Alliance has a pedestal centered in the back of their Alliance station. It's 18 inches round by 30 inches tall and is internally lit. The pedestal is used to stage the next ball to be fed on the field, and also indicates when the ball is available for play. This procedure is used to ensure that you will be able to put a new ball into play as soon as you score your current one.
The field crew will keep a ball queued up on the pedestal. When the pedestal is lit, the ball can be retrieved by the Alliance and fed onto the field by the inbounder. It will stay lit until a referee has indicated to the field system that there's been a possession. Once it goes off, the field crew will queue up the next ball. The light will stay off and the ball is unavailable until the ball on the field is scored.
There are dynamic things to be aware of back here this year. After a ball is scored in a high goal, it could drop on you, so heads up. Be aware of the field crew. They'll be clearing scored balls away during the match. They will try to stay out of your way.
A bunch of nerds who are going to be sitting around eating pizza and trying to build a robot. It's opened a whole new world for me.
Before I got in, I actually didn't know what to expect.
I had no idea what to expect.
I didn't know what I was getting myself into.
My career, my entire life.
The way they solve problems is unbelievable.
Ready to address big problems.
It helped me to take the initiative and problem solve.
I thought it was just like a small little organization, and it's so much bigger than I ever thought this would be.
So I expected to get some electrical training. I'm prepared to be an engineer.
A whole different perspective of what I want to do with my future.
This is what I want to do. This is so cool.